One of the greatest advantages to fuel injection is its low maintenance. However, there are some adjustments that will have to be made periodically to maintain proper engine performance. Since this is a throttle body style fuel injection with multiple throttle bodies, the throttle body synchronization needs to be checked and adjusted from time to time. Just like a carbureted engine that is properly adjusted and synced, an EFI-equipped engine whose throttle bodies have been carefully synchronized can mean the difference between a smooth-running, responsive engine and a rough-running, sluggish, or poor-performing engine. On new units, it's important that the engine is properly broken in prior to performing any adjustments. Refer to the maintenance schedule from the shop manual to get the recommended throttle body synchronization intervals. Synchronization is also required anytime the throttle bodies have been removed and disassembled. Today, I'll be taking you through a throttle body synchronization and TPS adjustment on the 1997 TL1000S. I recommend that you review the throttle body synchronization procedure in the shop manual, as well as the very thorough version found in the supplement to the 1997 New Model Update Seminar Manual. There are a few items that should be inspected prior to performing synchronization. It's important that the proper fuel type is being used. Refer to the owner's manual or shop manual to get the fuel recommendations. Check the engine oil type and level. Engine oil of the wrong type or level may affect the running of the motorcycle. For instance, if the oil level is too high, the air cleaner element may become contaminated during sustained high RPM operation, causing poor engine performance. When performing any service, always inspect the air cleaner element for contamination. Inspect the spark plug condition and type. Clean or replace as needed. Verify that the correct resistor spark plug is used for the model you're working on. Make sure that the plug gap is set to the correct spec. Check that both the throttle cable and fast idle cable have the recommended amount of free play. On this motorcycle, I've already removed the necessary components to allow access to the throttle bodies and adjustments. In fact, I removed more than what's normally required so that you'd have a better view of this procedure. Follow the procedure in the manual to remove the air cleaner from the throttle body. Remember, when the air cleaner is off, the throttle body is completely exposed with a straight shot down into the engine. Be careful not to allow any objects to fall into the open intakes. In fact, be sure to remove the bushing from the fuel tank. This is exactly the kind of object that could vibrate loose and fall right down into the intake. With the air cleaner removed, you need to remove the intake air temperature sensor and the intake air pressure sensor from the air cleaner housing and reconnect them prior to performing the synchronization. Without these sensors connected, the fuel injection system will operate in the relief mode and synchronization will not be accurate. Remove both sensors from the airbox. Don't lose the thin insulating washer underneath the intake air sensor. Reconnect the intake air temperature sensor to the green wiring harness coupler. You can hold the sensor in place with the wiring clamp that is located just to the right of the throttle body. Go ahead and just tuck it underneath there. Be sure not to allow the sensor's probe to touch the frame, as this will affect the sensor's readings. Reconnect both the vacuum hose and the electrical connector and allow the intake air pressure sensor to hang free behind the throttle body. Until I hook up the sync gauge, I need to plug this vacuum hose that was attached to the solenoid valve mounted to the airbox. This will prevent an air leak when I run the engine. I've warmed the engine up to operating temperature, which on the TL is about 160 to 190 degrees Fahrenheit. If necessary, use the idle screw to set the idle speed. On the TL, it's 1200 RPM. Since the throttle position sensor is connected to the throttle valve shaft, an incorrect idle speed may alter the sensor's adjustment, causing the engine to run improperly. Install the EFI test mode selector switch and use it to verify that there are no EFI failure codes present. The throttle position sensor provides the ECM with critical throttle information that is used for fuel injection and ignition operation. As we saw earlier, the TPS is located on the left side of the rear throttle body. The TPS should be checked and adjusted if necessary prior to performing a throttle body synchronization, and again rechecked after the synchronization is finished. The EFI mode selector switch is used to display a TPS alignment bar on the same LCD that displays the malfunction codes. With the ignition on and the mode selector in the on position, there is an alignment or adjustment bar that is visible just to the left of the code. There are 3 bars, but only one is visible at a time. When the TPS is adjusted correctly, only the middle bar should be visible at idle speed. It is important that the adjustment is made with the engine warmed up, running, and set to the correct idle speed. When performing both the TPS setting and throttle body synchronization, you want to maintain the engine coolant temperature between 160 and 190 degrees Fahrenheit. And you can use a floor-mounted cooling fan directed at the radiator and engine to help you do this. If the center bar on the LCD display is not visible at idle, then use a Torx bit to loosen the 2 adjustment screws. You want to get them loose enough so that you can move the TPS by hand. Carefully rotate the TPS until the upper bar is visible. Now there will be a slight delay of about a second as the bar display changes. We'll go ahead and rotate it. And now our upper bar is visible. Now slowly rotate the TPS in the other direction until the center bar just becomes visible. Use light pressure since a small amount of movement on the sensor will result in a large change on the display. So what I like to do is just tap on the sensor with my fingers. And I'm going to tap and watch that bar. I'm going to try that again. I might have went too far. Once the center bar is visible at idle, carefully tighten the adjustment screws. Keep an eye on the center bar as you tighten the screws so it doesn't move. And remember, you always want to keep the idle set to spec, which again on this model is 1200 RPM. Double check to make sure that the center bar is still visible and that the adjustment didn't change as you tighten the screws. Rev the engine slightly a couple of times and allow it to return to idle. Adjust the TPS again if the center bar is still not visible. As the throttle opens just past idle, the upper bar should become visible. A good way to verify this is to use the fast idle lever. Carefully open the lever until the engine RPM rises to 1400. The top adjustment bar should be visible at 1400 RPM and above. Go ahead and bring that up. If it isn't visible just off idle, then further adjustment of the TPS is needed. Remember, there is a slight delay as the bars on the LCD change position. Once the TPS is adjusted, at both idle and off idle, rev the engine and allow it to return to idle several times, just to make sure that the adjustment is correct. Well, now that the TPS is adjusted correctly, you can move on to throttle body synchronization. I'll use the Suzuki synchronization gauge set along with two small adapter hoses that are equipped with 1 millimeter air reduction jets, one in each hose. These air reduction jets installed in each hose will ensure that the sync gauge draws the same amount of vacuum from each throttle body. You can use an inline hose joint to connect the smaller adapter hoses to the balancer gauge hose. Remove the rubber cap and clip from the vacuum nipple on the front throttle body. It's located on the rear of the throttle body, pointing towards the rear of the motorcycle. We'll go ahead and pull that one off the bike. There are two vacuum nipples located on the rear throttle body. One has a rubber cap on it, and the other has the vacuum hose that routes to the vacuum transition valve and vacuum damper canister. I'll use the nipple that has the vacuum hose attached to it. However, leave this hose plugged for now. This will allow us to calibrate the balancer gauge using the front throttle body. The balancer gauge must be calibrated each time it is used. If not, the adjustment will be incorrect and the engine will not run properly. There are adjustment screws located on the bottom of the balancer gauge that allow you to alter the amount of vacuum going to each of the gauge's cylinders and steel balls. Here's an MTM tech tip that can make the calibration go a little quicker. Use a proper size T-fitting and connect one end of the T to a short piece of hose. Then connect the first two sync gauge hoses to the other ends of the T-fitting. Just like that. Now, you can connect the hose to the front throttle body at the vacuum nipple. Start the engine and bring it up to operating temperature and let it idle. Use the screws on the bottom of the sync gauge to adjust the steel balls so they're both equal with each other, and the balls are just above the middle line on the gauge. Now, using the T-fitting allows you to adjust both steel balls without having to swap the hoses around. Let's go ahead and adjust these. Want to bring that so it's just above that middle line. bring that one down. Want to get them both equal. If you're working on an inline 4 engine, you can use a couple of T-fittings to hook all 4 hoses up and calibrate all the steel balls at one time. And once the gauge is calibrated, shut the engine off and remove the T-fitting. Connect the number 1 balancer hose to the front throttle body and the number 2 hose to the rear throttle body using the adapter hoses. So we'll connect the number 1 balancer gauge hose to the front throttle body and our number 2 hose goes to the rear one, and we remove this vacuum line and connect the hose in place of it. There are air screws located at the left side of the throttle body. Before starting the engine, you may need to check these. Normally, these screws are preset at the factory and do not require adjustment. However, if they've been tampered with, they will have to be reset. These screws control an air bypass circuit that can affect low RPM synchronization, as you'll see when we balance the throttle body. I've already removed the rubber caps on the motorcycle. If it's necessary to adjust them, carefully turn the screws in, counting the turns until they lightly seat. Then, on this model, back the screws out 1 1/2 turns from this lightly seated position. So we'll start with the rear throttle body. And we'll count our turns in. There's a 1/2 turn. There's a full turn. There's 1 1/2. And well, we're just about at 1 1/2. So I'm going to lightly seat it and then back it out a 1/2, a full, and 1 1/2 turns. The screw on the front throttle body can be reached with a long standard screwdriver through this hole on the left frame rail. Now you may have to move the crankcase breather hose out of the way. And we'll go ahead and tuck that out of the way. Get it out from behind the radiator hose. There's also a wiring connector back there you have to watch for. So put the screwdriver in through the frame. Watch the wiring. And we'll get it on the air screw. Now we'll count the turns in. There's a 1/2. There's 1. And there's 1 1/2. So that one was set pretty good. So we'll bring them back out from the lightly seated position. 1/2 turn. Full turn. And 1 1/2 right there. Now start the engine and let it idle. It helps if you hang or hold the balancer gauge so that it is tilted back slightly. This will help damp the movement of the steel balls. If you want, you can use a rubber band as a movable alignment mark in case the steel balls aren't close to a line. Now, if a steel ball happens to stick near the top of the gauge, like you saw earlier, just press your finger over the air hole of that cylinder. Now, this will allow the ball to drop back down. At idle, the height of the steel balls should be even between throttle bodies. If they aren't, then you'll need to adjust the throttle body balancing screw, which is located on the right side of the front throttle body. There are two screws here. The larger Phillips screw that is further forward is the throttle body balancing screw. Now the smaller standard slot screw is the fast idle adjusting screw. Turning the balancing screw will change the balance between the throttle body. If I turn the screw clockwise, we'll see the ball on the number 1 cylinder starts to move up, indicating higher vacuum. Turning the screw counterclockwise brings the number 2 cylinder's ball up. So what we want to do is get them even. Be careful not to push down on the sync screw because that will affect the synchronization. And you can hear our idle changing. So throughout this, we want to maintain the correct spec, which is 1200 RPM on this one. Bring that up a little bit more, I think. And we're starting to look pretty good right there. Check our idle, we're sitting good. Each time I make an adjustment, I rev the engine slightly and then allow it to idle back down. Stuck one of our balls up there. Pull that down. Now this will ensure that I'm getting accurate readings on the sync gauge. Also, remember to be sure that the idle remains to specs, which is 1200 RPM on this model. So our idle's a little high. And the balls are looking pretty even. Once I have the height of the steel balls equal, I'll check the sync at 2000 RPM. If the balls are not even, at 2000 RPM, we'll use the throttle body balancing screw again to sync the steel balls. Okay, it's a little high on my idle there. Well, we might be able to just adjust it a little bit. Keeping the idle at 2000. I think that looks real good right there. Now double check the balance at idle. And if it's different, you can use the air screws on each throttle body to fine-tune the synchronization. Now ours is looking pretty good, but I'm going to go ahead and adjust the air screw on the rear throttle body just to show you how it'll affect this synchronization. I'm going to go ahead and turn it in about a half a turn. And you can see that the rear cylinder's ball went up just a little bit. So let's go ahead and turn it in a little bit more, and you'll see how it changes. And then we'll back it out. Let's back it back out to our original setting. And we're looking pretty good right there. A little patience will pay off in the long run. As I mentioned earlier, careful and precise throttle body synchronization can really make a difference in how the engine runs, especially at lower RPM and light throttle operation. Well, once you're satisfied with the synchronization, set the idle speed to specs. And throughout this whole process, be sure to keep an eye on the temperature gauge. Don't let the engine get too hot, or this will throw off your synchronization efforts. Give me a few minutes to remove the sync gauge and install the vacuum nipple caps, the vacuum lines, and the throttle body air screw plugs. Then we'll finish up with our throttle body adjustments. Once the synchronization is done, you'll need to check the throttle lever gap. The throttle lever and its stop screw are located on the right side of the rear throttle body. Proper adjustment of the throttle lever prevents the throttle valves from sticking in the throttle body. This could cause improper running or poor throttle operation. Use this small slotted screw and lock nut to set the throttle lever gap to spec, which on this TL is 0.25 millimeters with the throttle closed. Measure the gap between the throttle lever and the stop screw. Use a thickness gauge and be careful that you don't press on the lever, that the gauge that you've selected isn't too thick and moves the lever. Once the gap is set, tighten the lock nut. Install the air cleaner back on the throttle body. Don't forget to disconnect the air temp sensor and the intake air pressure sensor from the engine and wiring harness and reattach them to the airbox. Remember to install the plastic insulating washer between the airbox and the intake air temperature sensor. Reconnect the crankcase breather hose and any other vacuum hoses that were removed upon disassembly. Make sure all hoses and wiring are routed and secured properly.